I'm Amir. I run Bernardo Kastrup's weekly Q&A membership program with realityinmind.com. And this is an excerpt from one of those sessions in which we were joined by Michael Levin as guest, filmed on the 26th of September 2025. If you enjoy this, you might like to join a Q&A that we're hosting with Michael Levin and Bernardo Kastrup next week, the 18th of November. You can find us at withrealityinmind.com or join it as a one-off event via the link in the comments and description below. I at least haven't hosted a dialogue between you now in over a year, so it felt like, wow, time really flies. Have you had other dialogues together outside of the last one?
No.
We've had, okay, so everyone, if we've watched those last three. So I thought I'd just give you a quick recap of where you got to in the last conversation, partly so uh, remind you, then you can update us on where your thinking has changed if it has, and you can obviously also tell me if I've completely misunderstood you both. Um, but in the last conversation, my understanding was that you both agree that reality is most likely a field of subjectivity. Um, Michael, already then you were speaking, you've spoken more publicly about it now. You intuited a Platonic realm that evolution might be exploring, which, by the way, might resonate, I think, Bernardo, with what you spoke of last week as the universe having a kind of cosmic itch to know itself. So evolution might be one way it's exploring itself via manifesting its potentialities and experiencing itself from different viewpoints. At the time, it sounded like you had different intuitions about where the boundaries of agents and things might be. Um, it sounded like you were more sympathetic and increasingly so, Bernardo, with IIT. You had some reservations about IIT at the time, Michael. So be curious on an update if that's changed. It sounds like you're working with someone with IIT at the moment. Um, and that translated into Bernardo, your instinct to it being to do with life. And then Michael, you were struggling to see, well, where is the boundary? When does life start? You didn't see fecundation as more significant than the things that happen just before and just after. Um, and then, yeah, Michael, you said a few things that you felt like potentially even particles have very small, very tiny, but not zero cognitive light cones. And the other difference I noticed is you're more sympathetic, I think, Michael, to agents having nested agents within them. Whereas if I've understood you, Bernardo, you're more in the IIT realm where smaller complexities will get integrated into the larger, they won't be nested one within another.
Correct. Yeah, the subjectivity of the subgraph encompassed in a larger phi graph subsumes into the higher phi one, and they cease to have subjectivity of their own. They become enfolded into the subjectivity of the higher phi. That's IIT. I'm not saying that this is what happens in reality. That's IIT.
Yeah. Whereas Michael, you've sometimes had the you deliberately cartoonish metaphor of one neuron speaking to another, and maybe they have their own perspectives on their world, and they're obviously also part of the larger perspective that builds up the self that we call us. And then just my final point, I'm kind of summarizing. You had 6 hours of conversation, so this is my like rapid fire thing, so you can both tell me if I've first of all if I've misunderstood, and second if your thinking has changed, and then we can continue from there. It sounded like the Carl Friston's work on Markov blankets might be a bridge between your views as a potential new definition of life. And Michael, you've done some work on potential definitions of life since last time as well. A really amazing paper that I recommend everyone have a look at. Um, so perhaps maybe starting just if there are any red flags about what I said, just like that is not what I meant for either of you, please do let us know. And then we can dive into if you've updated your thinking, and perhaps there's a lot of curiosity from the group about that difference of opinion of, great, everything's potentially appearing in consciousness, but what is an agent? What isn't? Where are the boundaries, if there are any? And how can we find out what those might be? Perhaps whichever of you feels like you are most misrepresented, you could start.
Michael?
Yeah, I don't feel terribly misrepresented. I guess just a couple of things. I don't have anything against AIT. I think it's actually a really good formal model for computing some of these things. Um, I'm skeptical of the extra postulate that says that there's really going to be that in any system there's really going to be any one central experience. Overall, I think, and I'm sure we'll get to talk about this, but I want to just say two things that when and if we do get to talk about this Platonic space stuff, um, I use the name, and I may need to change the name at some point. I use the name now not because I'm trying to stay close to what Plato thought, because I think I depart from that in many ways. I really just I started using it because the mathematicians immediately know what I'm talking about, and it makes it clear to people that this is not some new thing that I claim to make up. That this is a view that goes back to Pythagoras and probably long before that, and so that helps me make that connection to existing thought. But a lot of people critique me for stuff that on this where I'm like, but that's Plato's thing. That's not actually that's not quite what I'm saying. So we have to kind of talk about that. And then again, this idea that ultimately I do think idealism is much closer to what's actually going on. But in the meantime, in order to make progress on the things that we need to make progress on, the model that I have currently is somewhat of you could call it somewhat of a dualistic model. And I do think it's an approximation, but in the end, but I think it's an approximation that's for now very helpful to get us to the next step of things that we need to do. So I just want to say that that's why I don't think it's the final story, but it goes far enough past the current physicalist story that it's already plenty weird for everybody, and very kind of uncomfortable for a lot of people. So that's good enough for me. I don't I don't need, at this point we don't have to go. I think all the way yet, but yeah, we got enough issues here.
Robert Lawrence Kuhn has come out publicly a few weeks ago saying that his intuition, and this is a guy who had studied all 350 theories of consciousness out there over a decade. So he came out saying that his intuition is closer to a form of idealist dualism. So at a fundamental level, yeah, mind, always mind, but there is a dualism entailed within this field of mind between self and world. And I actually sympathize with that quite a bit. I don't feel that I can argue for it with the same level of strength that I can argue for the base level idealism. So I don't talk about it normally because I don't feel I can defend it properly, right? And even Robert, he also made very clear that he only disclosed his intuition because Hans Buster pressed him a lot, because he also can't just defend that. So when we can't defend it, we tend not to say it. But you're not alone in the dualist intuition.
Yeah.
And I'm closer to that than I think you would, than I let out normally, because I just don't say what I don't feel I can defend as well as everything else I say. So I don't want to dilute that. But there may very well be a form of dualism sort of on top of a basic idealist model at the level of ontology. Regarding IIT, you didn't misrepresent me, Amir, but just to preempt a possible misunderstanding. It's not like it is a 100% overlap between analytic idealism and IIT, because, and that's also the point where Michael and I have different intuitions. I do think life is special. And IIT would say that within an organism, there are many complexes. It's not only one. And outside life, there are also complexes. Julio talks about ontological dust, the minimum phi complexes that are out there and correlate with some physical entity or substrate, as they call it. I have had this discussion with both both Giulio and Christoph several times. I think that once you have a set of phi complexes that whose internal entropy is actively maintained at a bounded level with an upper bound, and that's Kalfrist and the free energy principle and Markov blankets and all that. I give credence to that. A lot of people say, what is that? Nobody understands this. How are we going to take it seriously? Well, I understood it once. If I read it again, I don't think I will understand it again unless I spend a couple of days on it. But I remember having understood it once and having concluded, this is not nonsense. There is something here. Friston does make it difficult because he keeps on crossing, mathematical language, and then he goes back to English. And he fills in some important steps in English, and then he goes back to the equations, and then he goes back to English to fill in some. So that makes it almost annoying, like you're changing your language in the course of your argument. But I understand the reason he does that. It's very difficult to do it in any other way. But I think life is a actively enforced dissociative boundary, because even though IIT accounts for dissociation, the formation of what Giulio and Christoph call fault lines. If you run the mathematics of IIT, there comes a point where if a complex keeps growing, the empire keeps growing, there comes a point where adding more leads to a dilution of integrated information. So you actually are better off to maximize information. You're better off cutting off parts of the complex. And that cutting off, those fault lines are dissociative boundaries. It is exactly what it is. So IIT gives us a mathematical account of how and why dissociation happens. Just by trying to maximize integrated information, you get dissociation. You get it for free. But I think life is peculiar in that it's not a spontaneous dissociation as modeled by IIT, but an actively enforced one that has evolved to maintain bounded internal entropy. So I think this idea of Markov blankets and life being a system that maintains internal states that are inferential states, so to put an upper bound in internal entropy, I think that is something we can merge with IIT at some point. But it's not work that is already done. In other words, I don't think IIT is complete. I think it's a fantastic starting point, probably a sufficient starting point. Sorry about the noise. There is a lot of geese flying over my house right now and screaming like there is no tomorrow. I don't know whether you picked it up. I could hardly hear my own voice. So I think there is still some way to go. How do we model a Markov blanket under IIT? Because now it's not a spontaneous dissociation and fault lines. Now there is an active enforcement mechanism that maintains that boundary around a great number of complexes, not just one. And I think we will make some progress theoretically in IIT. There is some funding now. It's very difficult to fund theoretical research. Now we get a lot of funding for experimental stuff, but to fund theoretical stuff in IIT is very hard. We got funding for 2 people last year, or even the year before that, I forgot. But there is work still that needs to be done. So it's not like, I'm not saying that, okay, IIT is what analytic idealism needs in terms of mathematical formulation to account for everything. No, I think the Markov blanket story, the actively enforced dissociation, still needs to be explicitly formulated in IIT mathematical language. In other words, there is one more driver there. It's not only maximizing integrated information, because I don't think that's what life is doing. What life is doing is trying to preserve its own patterns. And so there is a different driver than maximizing information. It's preserving a pattern. And I think if we work a way to add this second driver into the mathematics, now we are getting closer. But yeah.
Feel free to respond to that, Michael. But also in the last conversation, you said that you felt autopoiesis had more to do with mind than life. You made a distinction between mind and life. So I wonder if you could work that into your answer in terms of what you mean, that could something have a mind and not be what we think of as life, and could something be alive and not have any kind of mind?
Yeah, well, sorry. Yeah, right. I mean, okay, we recently, I did this thing where I polled a bunch of people from various relevant fields for a definition of life. I said, in less than three sentences or less, definition of life, right? And we collected, I don't know, 62 or something definitions. We ended up having to use AI to analyze it, to build a morphospace of the different definitions, because they were basically not, in agreement almost at all. But we did pull out some interesting threads. I think that right, what Amir is referring to is basically my comment that a lot of times when people talk about life, they really get caught up in either material chauvinism, so they want to see some wet, squishy carbon, or they want to see some brains or something. And so I think for me, far more interesting than that is the kind of stuff that Bernardo was talking about, which is what's really what's actually fundamental here, right? What's the interesting thing and so for this reason, I think the thing that underlies all of this is a spectrum of cognition. What we're really looking at is what kind of mental life can this thing have, and we call life those things that are particularly good at scaling up and aligning the cognitive light cones of their parts, so that they end up in this like multi-scale thing that does where the parts end up doing things that the collective doesn't do. But overall, like one of the things that we've been doing most recently is studying this. I don't even know how to call this phenomenon, but this notion of getting more out than you put in, basically both on the biology side and the computer science side, because we've had part of what I'm doing is trying for like maximum shock value with these incredibly simple, minimal systems, right? Biology. The thing with biology is that somebody could always say, oh well, there's more mechanisms for this. You just haven't found it. It's quantum biology, or there's something underneath it. So I like these very minimal systems where you can see all the parts. There's no more components to be found, and what we're finding is that the best way to put it, I think, is that all the theories that we have, the formal models of computation, of evolution, all these things, the formal models that tell you what it should do and what it can't do, are pretty good formal models of the front end. Like, I think all of these things are kind of thin clients at this point, and the models will tell you some things about that front end, the interface. But what they fail to capture is what's going on the back end, which kind of seeps through all of these things. And I'll give you some examples in a minute. But one of the key things is that a lot of people will say, well, that's great for biology. Yes, we know with biology you get sort of more out than the laws of biochemistry will tell you. But then there's this other corner of the world, which is machines, and it's like these boring things that just do exactly what the algorithm says, and those aren't like that. Those don't get any of the magic. Only sort of the furry squishy things get the magic. And as far as I can tell, everybody gets the magic. In other words, all the way down. Now, the magic you get as a mammal versus as a minimal cell versus as a very minimal physical system, that there's different degrees and different kinds. But I don't believe that these things basically, I think these what I call these ingressions from this latent space they seep into everything. In fact, I call it. So here's a crazy theory that I just was trying to formalize a couple of weeks ago. This notion of steganography, where you have like an image of a cat or something, and in any data set, there are some bits that if you flip the bits, nothing really changes. There's sort of like degrees of freedom and so steganography is when you hide messages in the loose bits. So if you're a spy, or if you're an artist who wants to label it with their name or something, you find some bits that don't change anything, and then you can write your name, and nobody knows it's there unless somebody knows, and then they can pull it out. And so the only rule of steganography is don't mess with the main thing. In other words, if the main thing changes, then no good, right? You can only use as much as the degrees of freedom that won't screw up the main thing. So this is what we're seeing. It's almost like a situation where I call it like Platonic foam or something. It's kind of like the quantum foam, where whatever spaces you have that are not determined by your algorithm nor by some kind of randomness, but even the simplest, dumbest things have some room for this stuff to seep in there. And it's not chance and it's not necessity. It's this weird third thing that shows up, and it's stuff you can do not because of your algorithm, despite your algorithm. And this is very interesting to me. And this is kind of how I'm thinking about I'm writing some stuff on free will and whatever. It's like it's not the computationalist idea that you're conscious because you're doing an algorithm. That's not why you're conscious. It's not because you're doing the algorithm. It's in spite of the algorithm. It's in spite of the fact that yes, there's an algorithm. Yes, there's physical facts of physics that constrain your body, all these kinds of things. How much can you do despite all of that? And even the dumbest, simplest things can do some stuff. But I think the things we call life, I think life is a label that we put on things that are amazingly good at it. In fact, they're so good at it that even dumb humans like us can notice it. That's I think the big trick, because if you're so good at it that even the rest of us go, oh, I mean, this thing clearly is doing more than than the algorithm and the materials say. You're alive and you're fantastic at it. These other things, people, we're looking at some things that people have looked at for decades and not seen it, because it's subtle and it's small, and because we've internalized, at least most of us have internalized this idea that the world is sort of split. There are these like inert matter and these dumb machines that just do exactly what that our formal models are perfectly sufficient for this. And then there are these magical living things, and we all know that computational metaphors are not sufficient for living things. But over here they're fine. I don't think they're fine anywhere. I think in all of these cases there's sort of decent models of the front end, but everything's a front end. Like none of these things are really what we think they are. And so and we're trying to exploit them. So we have some of the biology and we got some computational stuff coming that's really just very crazy, but it is most of that is still going through review, so it'll be out hopefully this fall. So that's kind of my thought on this now, that what we're dealing with all of this stuff are interfaces, and they're interfaces to a latent space, which is where the action is, which I think is where the consciousness actually is. And then it sort of projects through, and different degrees of it can filter in through the different interfaces that we make. And I do think that space is not a random grab bag of stuff. I think it's structured. It's a structured space, which is why I call it a Platonic space. And so, yeah, that's the kind of quick overview.
I completely agree with everything you just said.
You're the first one. That's the first time that's happened.
But I think I now understand better where the difference is. Let me first amplify what you just said. Try to amplify, because I agree with it. I think the magic is immanent in everything, because as an idealist, I think all matter is the extrinsic appearance of mental processes. Activity in a field of subjectivity, nothing is an exception to that, inanimate or biological. So I agree completely with that. The terminology I normally use is the archetypes of nature express themselves in all of nature, not only in biology, but in the inanimate world as well. Supernovae and black holes and quasars and whatnot. The difference I make, and immediately I will try to justify why I think the difference is important. The difference I make is, where do we put the boundaries of subjectivity? I mean, subjectivity is immanent in everything, but my subjectivity seems to be disjoint from yours. I have no direct access to your thoughts, to your feelings. That we are dissociated from one another. Now, subjectivity is immanent in my dissociated field and in your dissociated field. So the question for me is, where are the dissociative boundaries, which would define then the boundaries of a dissociated perspective within this one field of subjectivity? But that doesn't deny the immanence of the archetypes or the Platonic field into everything. For instance, as far as I can access through introspection right now, there is nothing it's like to be a neuron on my posterior hot zone as opposed to a neuron in my prefrontal cortex. I cannot access these separate, disjoint experiential fields. There is only something it is like to be me. But of course, my consciousness is immanent in all of my neurons. The magic is immanent in my prefrontal cortex, in my posterior hot zone, in my angular gyrus, everywhere. And yet, as far as I can access, there is only something it is like to be the whole of my nervous system. You see what I mean?
I do see, but I'm suspicious. I'm suspicious of that because right now, you and I are conversing here, right? And I know what it's like to be me. I don't know what it's like to be you, and all of that. But there are numerous non-verbal components that were never asked. I agree that it's possible that there's nothing that it's like to be them. It's possible, but I'm very suspicious of that conclusion when we don't have a way of asking them. Because I think it's perfectly possible to have a conscious experience and not be able to verbalize it in language. And so I was talking to Anil Seth about this, and I said, there are these, like, people talk about unconscious processes, right? Like some parts of vision are supposedly unconscious, and there's this, subliminal, whatever. And they said, unconscious to whom? I know that you and I will say it's unconscious, well, of course, but nobody asked all the other components. And how do you know that there wasn't some component that in fact did have an experience with this? So I'm just, I'm not saying necessarily, but I'm suspicious of them not being able to speak up for themselves in this way.
I agree even with that. If you take IIT, there are many disjoint complexes within us, right? The ego complex may integrate the most information, but there are certainly many other lower phi complexes playing out in the entirety of the nervous system and also in the rest of the body. Maybe kidneys don't integrate much information, but they do integrate some information. So under IIT, there would be all of these other complexes in us that the ego cannot report on because the ego has no access to them. The difference is that IIT would say that whatever is within one phi complex loses its private subjectivity, which then gets subsumed in the next higher phi complex. Yeah. That is the difference.
I get it. I understand the claim. I'm suspicious of it. I'm not sure because, well, I have a more practical question. Do you know, and this is maybe a question for Giulio, but do you know if phi levels can be directly compared? For example, let's say, because we're doing this now, let's say I do the calculation on a liver, on a kidney, right? And then Giulio does it on the brain. Can we compare those side by side and say who has more? Can you absolute comparisons?
Yeah. Theoretically, surely, yes.
Okay.
That was, you can even if you can't do it in practice, because IIT would say information integration goes all the way down to the quantum level. Of course, we cannot measure anything at that level of at that resolution. So we have to make simplifying assumptions. But even in practice, you can infer differences in phi level. That is the basis. Remember the adversarial collaboration they had with the global workspace theory folks in 2023. So of the three questions, IIT was better in two, and the third one was sort of, we didn't know who won there. But in one of the questions that IIT won, the estimate was based on the anatomy of the posterior hot zone, because the architecture of the connections through axons and dendrites, the interconnect network is much richer in the posterior hot zone than in other places. So you could infer that's where the higher phi is. So it is possible to look at the liver and look at your default mode network.
Yeah.
And even if you can't put a number, you can say with very high confidence, one has higher phi than the other in potentiality.
Well, so I'd like to go the other direction. So structurally, doing it structurally by connections and all of that, I'm also a little suspicious of that. And so what I would rather do, which we have done, is to take estimates of surrogate metrics like phi d or some other. I mean, there's a million of them, right? So things we can actually compute, and do it on the actual functional. So in the brain, you can do it on the electric signaling. In the liver, I can also do it on the electric signaling or on the calcium signaling. So we've done this, and this is Thomas Varley's work at the Bongard lab. You know, we can do it on tissues, and we can do it, and we have data on brains. And I just wonder what would happen? What would the IIT response be if we said, yeah, by the way, the liver one is higher than what you're pulling out of the, you know, out of the cortex or whatever? Like, what are they going to say about that?
When you,
I'm not saying, by the way, I'm not saying that that's the case. This is very early days. Okay. I'm not claiming that that's what we found. I'm just saying this is now doable. We're doing all this stuff. And I wonder what would happen, you know?
Okay. There is a fundamental thing in IIT that I think would help you understand what their perspective would be on the question. In IIT, it is essential when we are calculating integrated information in the transition matrix. It is essential in that TPD, right? Is the name transition whatever. It is essential for you to specify what are the possible states, the counterfactuals of the current state of the system. In other words, if the system is in state A, but it could have been in state B and only B, then that entails less information from the fact that it is in state A compared to if it is in state A, but it could have been in state B, C, D, E, and F. So the possible other states define how much information is in any configuration of the system. And that's where anatomy plays a role, because the richer the interconnect structure in the anatomy, the higher are the other possible states, and also the causal links across the states. So it is possible from an IIT perspective to say in principle already that given the structure of a liver, you will fundamentally have lower phi than any other part of the nervous system, any part of the nervous system.
Yeah, I mean, I understand why that is an attractive feature for phi, because it naturally points to the brain and all of that. But you know, we see bioelectric states in cells, and the richness of states, and we can discretize it. It's fine. We can see discrete states, but the number of different states that even a single cell can be, and it has, you know, it's 3D, so it has like all cells in its environment that it's touching, and right, and the different basically the different combinations and the different discrete cells it can be is enormous. And I think we could have a good discussion as to whether the neural case is you know, whether leaning on the physical connections versus the actual observable states, right, the physiology, which we think is what you know, the signature of its whatever thinking it's doing or not doing. You know, I would put those two up against each other, I think, any day. And I think it'll be very interesting to actually compute that stuff. That might be actually an interesting adversarial collaboration, is to actually to really calculate that through as best as we can.
Wouldn't you say that however rich it is in the liver, which is pretty uniform tissue, that however rich the states can be, the causal power of a highly interconnected anatomy is fundamentally always higher? In other words, even if the liver is... Go ahead.
I mean, homogeneous, first of all, it's not that homogeneous. It actually has quite a bit of structure, but also, again, homogeneous at the anatomical level is not the same as homogeneous in terms of physiology. Like when we look physiologically, I mean, I could show you some videos, not necessarily of the liver, but other stuff. It is crazy in there. The kinds of things you see, they look totally as complex as what you see when you look at brain, when you look at the kinds of calcium waves you get in the brain and stuff. It's very similar, slower. So we can usually these things are minutes, not milliseconds. Okay, fine. We can talk about whether there's a like Nick Humphreys thinks there's like an absolute time constant here that's important. I don't know, but so they're slower, but they're extremely rich. And there's a lot going on. So I don't know. I feel I think we're going to have metrics, and I think the fact that it doesn't do language, at least I don't have any evidence that it does language. Who knows? Really, that's we have to be very careful with that stuff. That's all I think.
Yeah, there is, what I believe to be the weakest point in IIT, and I'm saying this as a supporter of IIT. And my saying this doesn't mean that I am any less a supporter of IIT than I am. I think this is a weak point, but it's completely justifiable given everything else we get from IIT. But the weak point is that in the counterfactuals, the other possible states the system could be in, which define how much information there is in any given state, we count in the transition probability matrix, the TPM, we count all counterfactuals, not only the reachable counterfactuals. In other words, if there is a counterfactual that the system can never reach in the course of applying its own rules to itself, suppose you have a mathematical equation and you run through all the inputs of that mathematical equations and you get the outputs. Certain outputs, given the structure of the equation, will never be produced. Doesn't matter the input. So those are unreachable counterfactuals, right? So the TPM collects all counterfactuals, not only the reachable ones. And then it gets tricky, right? Because does it make sense to count counterfactuals that can never be reached to calculate how much information is encoded in a reached state? So that is where theoretically it gets tricky. But
yeah,
in terms of the reachable states that can be observed, because that's what you were talking about, right? If you take a microscope and you look at what's happening in the liver, it's frenetic activity. I'm tempted to imagine that if you did the same in the brain, it would be even worse. It would be even more, and with more causal links over longer distances, over micrometers.
Well, we will. I mean, this will be known, right? This is like a really good scientific question that we will know the answer to this, I think, in the next couple of months. But one thing that might be fun is maybe what I'll. Yeah, there'll be other giveaways, but what I was thinking of is to actually make videos, tweak the timing so that they're going at the same rate, and ask people to guess which one of these things is the brain. I think Tononi would still guess because you can kind of because of the structure, but I think it would not be trivial. I think it would not be easy to guess. I think most people would be surprised at how hard it is to guess. You have to look the right way. Nobody really looks at the things that that we're looking at now, and the things that we see. Like these things have never been examined that way.
That will be interesting to see.
Yeah.
I'm open to that as an idealist. I'm not a brain chauvinist. I think mind is immanent in everything, and I feel like smiling when I think of the hypothesis that my liver is a lot more conscious than I give it credit to. I like that idea. Just to complete my dump on you of IIT relevant things. There was this paper last year, I think, that gave some credence to the idea that there actually are coherent quantum states in the brain, in the microtubules, and that they can go over long distances, not nanometers, but micrometers, 3 orders of magnitude more than we suspected. If that is the case, then phi explodes in the brain. It is just a geometrical explosion of causal powers, if that is true.
Yeah. I should have. I maybe I can find it while we're talking. I didn't prepare. I have some videos of what microtubules look like in other cells in your body. I mean, wait till you see this. Like, I mean, this is not, we're not unique. Other people have done videos like that too. It is insane what's going on. And, you know, and people like Jack Tazinski and Craddock and such have talked about as like, you know, microtubule dynamics as a generic medium of memory and things like that, but they're everywhere. They're everywhere. You know, you get them, you know,
every cell. Yeah.
every cell has them, and
Yeah.
they're extremely dynamic and you know and rich. So yeah.
Very interesting, Michael. I'm looking forward to seeing what will come out of your liver studies under IIT.
Yeah. Yeah, we'll do it. I mean, we're doing all of it. Xenobots, anthrobots, body tissues, you know, weird hybrid constructs that we make, like all of it. Everything is getting profiled. Yeah.
Maybe we have ego chauvinism. Maybe my ego is trying to say, no, I'm better than the liver. You know, I'm right here in the tower. How can those guys down there be richer than me?
Yeah.
In
I
any
mean,
way?
look, okay, you know, okay. I mean, to be fair, there isn't any evidence that I know of for proper grammar, like an infinite generative language grammar in these other structures. No, nobody has shown that, right? So when I say it's this, you know, these things are the same, I never say language because we don't know. It could be, but no one has shown that. And maybe there is something special about the architecture in the brain which is uniquely suitable for, like, you know, like real language and, you know, and all of that. Maybe. I don't know. I've been thinking, I haven't worked really hard on this, but I've been thinking about doing a kind of grammar in analog computing to see if that's possible. And because typically it's like very, like, you know, discrete, right? And if that's the case, what would that look like? So if we saw, and some people, you know, like Andy Adamatsky did argue for language in slime molds and things like that based on readings that he did. I mean, it's very hard, right, to really prove that stuff. But we should at the very least we should have ways of checking, you know.
But if there is a Turing complete machine, it is capable of language. And even Conway's game of life is Turing complete.
Yeah.
So if the idea is it in principle capable of a grammar, I think the chances are extremely high that the answer will be yes. Anywhere you look in the organism. I mean, it may be a very cumbersome way of implementing a grammar, very highly inefficient, very slow, cumbersome, difficult. But if it is Turing complete, and it's very easy to be Turing complete, you need like 8 operations. You need to be able to move things. You need to operate to apply some computational operators. If it is Turing complete, it's grammatically capable.
Yeah. So, you know, right. So I don't know. Maybe you know, the ego on top is maybe it's special, or maybe it's just the one that's very good at making the case that it's special.
That it's special,
know?
Yeah.
It's just very eloquent. He's got some beautiful language, and it's you know,
Yeah. Cool.
Brilliant. Reminds me, of course, the discomfort that a lot of people had when some proposed that the Earth wasn't the center of the galaxy or the universe, or it's quite a conceptual shift. Would one of you mind summarizing, if it's possible, the conversation you just had? Like, is it? Well, I could do my best. And tell me if I'm off and if I'm missing major details. But it was on the tip of my tongue, brain chauvinism, where Bernardo, on account of IIT and for other reasons, you feel like there's a higher complexity of cognition and awareness that might be happening that looks like the brain. And under IIT and in your model, there might be a dissociated rather than nested something it is like to be my liver, but it's probably far less sophisticated than what I think of as my cognition and awareness, or in Michael's terms, cognitive light cone. Whereas Michael, you've seen in your experiments and your intuitions and your observations of how so many times we underestimate the abilities of other systems because we're not good at looking at their capabilities. that it's something to be tested empirically, and that's what you're trying to do, and you don't want to discount it too quickly, and that we're chauvinistic in other ways of we look for things that are like us, but it could be the complexity is in the biological signals or something like that. Is this close to? And you both seem open to each other's.
Yeah. I mean, the other thing that I should point out is that, it's not just that we're chauvinistic, it's that we have a very particular, because of our own evolutionary history, I suppose, we have a very particular mind blindness where much like in the so I use this analogy of the electromagnetic spectrum, right? It's like, naturally we see like this tiny little sliver of it, and also all the other stuff, static electricity, lightning, magnets, light. We used to think all those were different things. And so then we had a good theory of electromagnetism, which says, first of all, they're not all different things, they're manifestations of the same thing, so there's a powerful unification that happens. And second, okay, now that you understand that, you can now create devices to operate, to sense, and then to send and receive along this enormous continuum. So I feel like, in the spectrum of minds, we are like that. We are extremely narrow. Even if we don't want to be chauvinistic, we have a lot of trouble recognizing very alien minds. And when I say alien minds, actually there's a talk I give where I progressively get to weirder and weirder kinds of things. But even just let's just go with cells, for example. In a typical cell, the space that it's navigating, well, there's several spaces that it's navigating, and who knows the ones we don't even know about, but the ones we know about, for example, transcriptional space. So this is the space of possible gene expression states. And so think of this as like Moravec's paradox. We have a robot with 10,000 limbs, and how do you run a robot with that many effectors, right? Yeah, this thing has 20,000 different dimensions that it can act in. Not 20,000 different behaviors, 20,000 different dimensions. We don't even, like, I don't know about you, but we can't even begin to comprehend. And I mean, I know mathematicians have crazy Hilbert spaces and whatnot, but for the rest of us, what is a mind like that? Yeah, you're not going to talk to it about politics or the movie you saw, whatever. But if you were smart enough, you could talk to it about what's going on in transcriptional space and the different attractors and the different domains and the places you shouldn't go and the places you can't help but go, and the place where you were yesterday, which was amazing, but you can't get there today because something is going, like 20,000 independent, or mostly independent dimensions. And those are the kinds of things where it becomes very hard to say who's more and who's less sophisticated. We want to think we're more sophisticated than cells, but I can't navigate a 20,000 dimensional space, right? So I feel like it's very hard to really to be able to say, we know what level of sophistication is and the problems they solve. I think we've talked about it before, that this example of barium, where barium experiments in planaria, where we hit these things with a toxin they've never seen before, that there's never been evolutionary pressure to know what to deal with. But their heads blow up, and within a matter of days, they grow a new head that's totally barium accommodated, no problem. It doesn't care about barium. And so, how the hell does that happen? And out of the whatever 20,000 sets of genes, they identified less than a dozen different dimensions that they had to walk in to get to a place where physiologically that stressor doesn't bother them anymore. And they've never seen this before. So it's an incredible amount of problem solving. Like, how do we compare that with the kinds of things that we do? I don't know. I don't know that we can just say it's less sophisticated.
I'm totally with you. Also in the intuition, let me amplify something you said before, and I wanted to amplify, but I forgot. You said the question is not what it can do because of the mechanics. The question is what it can do despite the mechanisms, the mechanics. And the intuition is there is this immanent complexity or immanent intelligence that is behind everything. And some of the mechanics we impose on it may be limitations and not enablers. So I completely agree with that. In computer engineering, we call it signal to noise ratio. In other words, we deliberately want to kill its expression. So a computer does only what it set out to do. And that's why it is digital, because there is no such a thing as digital in nature. In nature, everything is analog. Everything can occupy any value within its boundaries, but there is a continuum of values. But what we do as computer engineers, electronics engineers, we say, If it's doing something below this threshold, then it's 0. Only if it crosses not only this threshold, but hysteretic threshold above it, and then it's doing something here, then it's 1. But whatever it does within above this threshold, it's still 1. So we ignore the vast majority of what it's doing, and we do it because we want the computer to be predictable. We want to know what it's going to do. We want to know that it will do what is in the program. But it is an artificial limitation we place. But the point, Michael, where my passion for the difference I have with you kicks in is the whole talk about conscious AI, which makes me want to vomit. And the reason is I admittedly cannot prove that an AI computer is not conscious in and of itself. In other words, has a private, dissociated inner life that is coextensive with the physical boundaries of the computer. I cannot prove that. But there are a great many things I cannot prove, and which make no sense entertaining, because they are far out hypotheses. And under IIT, if you look at an AI computer, a transformer, a large language model, there is only one steady re-entrant loop, and that is when you produce a token at the end, you append that token to the query. That's no information integration. It's vanishingly small. It's a feed-forward system with very, very, very little integrated information. So from a point of view of IIT, a computer is an aggregate, not a complex. It's an aggregate of ontological dust. It is not a thing unto itself. It's part of the bigger thing that is the universe. And yes, the magic is immanent in it, just as it is immanent in my bottle of water and in the stars and my table. But my passion has to do with, what some philosophers in the UK do, start to think about the ethics of AI and the moral or human rights of AI, because I think that is the meaning to the human condition. I think to start investing money into studying the suffering of AI computers, while there are so many bazillions of human beings suffering beyond our ability to conceive, I think that is a very bad thing. And it also reduces us to a mechanism, because as I told you, a computer is made to block the magic. That's what it's made to do. So if we say, well, it's conscious just like us, then we are demeaning ourselves. We are lowering ourselves to the level of a mechanism that was constructed to block the magic. So this is why these emotions I feel as I'm talking about this to you have moved me to get out of retirement and go back into the fray. And this is no small thing for me. This was a major, my life was settled. I was pretty happy. I was all right. I had already sold one company. I didn't need to jump into this crap again. And here I am. So this is where my passion is, whether I'm right or wrong, Michael.
Well, so let me, maybe this is a good place for me to clarify. I don't disagree with anything you just said. I don't think that the standard reasons that people use to think about consciousness in language models, for example, what they're normally looking at is the fact that, well, it talks like us, and it even says it's conscious. Like, we have to take this seriously, right? That is so I'm in agreement with you. I think that the talking part is irrelevant. It's a total red herring. If whatever degree of consciousness has I think zero to do with the thing we're looking at, for the reason, I'm sorry about the noise, my phone is going crazy. The reason is what I said before. The talking is what we forced it to do. That's not the interesting part. The interesting part is what all of these things do despite what we're, right? Yeah. Exactly. So I'm in 100% agreement with you on that. However, what I've seen, and we're now quantifying this stuff, and you'll see there'll be more papers coming. When we make, and I agree with you, the point of computers was supposed to be to keep the magic out. That was the whole point. I think we failed. I think we succeeded, meaning that we have talked ourselves into this thing where we think we know what the algorithm does. We can see it. It does. I think it does some other stuff that if we notice, that's hard to notice, but it isn't. But it is emphatically not what the algorithm is doing. So by watching the talking and the whatever else, whatever the hell else it's doing, that isn't what we should be looking at. What we do need to do, and I'll tell you, for basically for the same reasons I think as you, we should be getting better at seeing this other stuff. Because, first of all, I'm not claiming that it's of equal significance as the human and the animal suffering that we know exists. So I'm not saying it's to that level. And no matter how sophisticated the talking, I suspect that has like nothing to do with it at all. However, we are in a position, I think, as humans today, where we are very bad at noticing other ways of being and ways of suffering and ways of happiness and all these things in unfamiliar embodiments. And I don't think it's going to be about AI first. I don't think we're going to make significantly conscious AI right away. It's going to take a while. But what we are going to have is humans that have various modifications and augmentations. And what I think is going to happen, and we have a graphic designer, this guy Jeremy Gave, makes these amazing illustrations, and I had him draw or maybe you've seen it already. It's this guy sitting in a park reading a newspaper, and like half his brain is his normal brain, and then the rest of it is like they had it augmented with whatever kind of digital whatever. And there's another guy sneaking up behind him with an old like an ancient phrenology device where they used to measure your head. And what he's trying to do is say, is this guy like 51%? Because if he's 51% machine, that's it. No, no good. He's not my friend. No rights, no nothing. Like, no good. You're a machine. You're not and less than 50. Okay, you're my friend. So this is I think going to be the first problem, because we as humans are really good at drawing stupid in-group out-group distinctions based on minimal factors that will allow us to be mean and nasty to each other. And I think we have to get beyond this simple idea that there are machines and we don't need to worry about them, and then there are humans and animals, which we should, even though we're bad at that too, but we should worry about them. And I think the problem isn't the AI. The problem is that if we stick with these categories and we don't mature to the point where we can ask the question, what is the magic? Can we quantify it? What determines when it comes through? Because we don't understand it well, because we're finding it now in a quantifiable way in very minimal systems where nobody expected to find it. We have to get ready for this kind of thing. Otherwise, I think we're going to have major problems. And it isn't because of language models, and it isn't because they talk. It's fundamentally because we don't understand that mapping between the interface and the kind of mind that's going to ingress through it. We're just not very good at it.
I think the magic percolates through everything. The magic is everywhere to a higher or lesser degree. But the key point to me is, because that's the origin of suffering, is the degree of separation and the scope of our separation. That's why we suffer. If we were the entire universe, we wouldn't mind if this little bit here is hungry, because I am the totality of the universe. So suffering is very highly modulated by where the boundaries are, the dissociative boundaries. So I think the question is, at least to me, is not where is the magic manifesting? It's immanent in everything. It's everywhere. The important question is, does the boundary of subjectivity correlate with the material boundary of the thing we are giving a name to, like a computer? Does the boundary of that computer, is it coextensive with the first person perspective of the boundaries of subjectivity? In other words, is there something it is like to be the computer in and of itself as opposed to the environment it is in? I think that is a very important question, and more important than is the magic there. The magic is it is everywhere.
Yeah, I mean, so the interesting thing now is, I agree with you. That is the question, and the interesting thing now is that we can move beyond like the more poetic kind of ancient idea that there's magic everywhere and whatever. We can now, at least to some extent, not claiming that we can see all of it, to some extent we can try to characterize which magic in which interface. And when I say magic, the kinds of things we see popping in are things like delayed gratification, self-modeling, right? Having a model of your neighbors and who you're interacting with, various problem-solving competencies. Once you start being able to identify those things, some of those are going to add up to, at some point, they're going to add up to a significant mind. In other words, this is not at this point like some kind of non-specific, ineffable thing that's everywhere. Like from specific interfaces, we can point to here's what actually came through this thing. Nobody noticed it because everybody was looking at the algorithm and the talking and the whatever. But if you look this way, here's what you see, and these are what they are competencies that would be instantly recognizable to any behavioral scientist. So I'm not saying this is just like us, incarnated in a log of wood. I'm not saying that. I'm saying that there are some things here that get you into the question of, I mean, people argue all the time, okay, insects, what's going on with insects, fish, snakes, iguanas, kind of not really cold-blooded, but kind of getting there for some of them, and things like that. Like you're on that spectrum already. And so I don't have evidence that we've seen, like highly significant things, but definitely not zero. And now we have to, now we have to start thinking, what would you need to see before you did start to worry? And it can't be, like, agreed with you, it can't be looking at what you forced it to do. That doesn't make any sense. That's irrelevant. That's a red herring.
Would you consider the presence of an actively enforced Markov blanket as significant for this question? Or would it be more a question of behavior?
I think it's relevant data. I'm not prepared to yet kind of say what the necessary and sufficient conditions are, but I think it's relevant data. I think knowing that is important. Knowing to what degree it does surprise minimization, so active inference, to what degree it builds a self-model, to what degree it can do counterfactuals, to what, right? Like all of these things are sort of evidence, and it's exactly what we do in behavioral science. You get a new, it's reverse engineering. You get a new animal, and you're sort of looking at it, and you say, okay, well, what the hell can this thing actually do? And like if you see, Eva Jablonka's book, The Sensitive Soul, it's like this, it's amazing, right? And she takes you through all the different primitive kind of steps. And so you start looking at these crazy new things and you say, so what do they do? Let's figure it out, knowing that we're bad at it, basically, especially, we do our best on the biology side, but with novel things that are not strictly biologicals, it's really hard.
Yeah.
But you're starting to see these things that are components of things you will have to worry about, I think.
The point you made about augmentation, I completely agree with that. I mean, it's not even polemical, right? I am augmented right now.
Yeah.
Look, my inner life has just changed a lot.
Yeah.
And it's for the worse. Oh, my inner life is augmented. Yeah. I see more. I see better. So this is primitive augmentation in the sense that it's just a lens hanging from the top of my nose, but there is no fundamental difference between this and this on the one hand.
That's right.
Or the computer I'm looking at, and wiring stuff directly into my neurons. So I'm totally with you there.
100%. And your toothbrush and your ability to boil water instead of having to drink alcohol all day, as they did, back in the day, right in the Middle Ages, and to keep from getting poisoned, and which unlocked. I mean, that's a theory, right? I don't know. I'm not a historian, but I read that basically the invention of tea was fundamental to the Enlightenment, because the discovery of tea, because basically, whereas before you would have to put alcohol in everything to kill the stuff, now people started boiling the water for tea, and suddenly it like unlocked all this sobriety that wasn't there before.
The latest indicates that was not quite true, but I know where you're coming from. I know
you get the
story.
idea, right? Yeah. And who knows? I don't have any idea. I'm just saying that yes, everything that we're doing is on the road to modifying our default scenario. And I'm very concerned, this business of, when they say proof of humanity certificates and all this bullshit, I'm very concerned about this, because we know where this goes. It doesn't just go to the language models. It goes, well, that guy looks like he's had some work done, screw him, right? So that's not we can't do that. We need to really have a better understanding of when these things pop up.
That guy measuring skulls and what threshold is crossed, that is extraordinarily dangerous, perhaps more dangerous than demeaning humanity, because now you have an in-group and an out-group, and there is just no reason to think of augmentation is making one less human. So that is extraordinarily dangerous.
That's what I worry about, is when we talk about the real consciousness has got to be this wet, squishy, proteinaceous stuff, right? And then the next step is that you're going to point to somebody else and say, well, then you've got less, and we don't need to worry, and we're good at that, right? As humans, that part we have down. So that's, I think we need to do better there.
Yeah. Very interesting, Michael. Always with you. A very nice conversation.
Likewise. Yeah, thanks, Bernard. Yeah, very good. Always interesting.
Yeah, it's exhilarating, and I wanted to apologize to the group to not managing expectations better, because there were several questions submitted before we started. I've been following intently the conversation, so I hadn't noticed there's 272 comments in the chat. But I know from our previous conversations that Bernardo and Michael have so much to converse with each other that there will inevitably be less time for our questions. But that none of what I just said, Michael or Bernardo, is to indicate that I would prefer it a different way. It's fascinating and exhilarating. People at the beginning said, "Oh, we'd love to be a fly on the wall at this Venice meeting," and then someone responded, "You're a fly on the wall right now." This is like, I feel incredibly privileged to be able to sit down in a conversation that I imagine lots of scientists and researchers and philosophers have in private, and for you to both figure it out together in public so courageously. I'll feed in one question, which, just to clarify something with you, Michael, if that's okay, which is, and perhaps you are both using some technical language at points, so perhaps you discussed it, but if you could find a simpler way of saying, my understanding of one of the issues that Bernardo was bringing up is, okay, well, I'll place the question in two ways. One is, do you resonate with Bernardo's model in which there's one field of subjectivity and what we call agents are dissociated whirlpools within that subjectivity? So my understanding is his lens is kind of top down, whereas a lot of your research is looking at the parts that build up into more sophisticated selves. So one is, do you resonate with that conception of that model of idealism? And then either way, the question, just to make it super simple, is, I could imagine, I was just trying to think of an example that everyone would be able to grasp, including me. I could imagine a spider coming across my hand and being like, oh, that looks a little bit like me. And let's say I'm asleep, and it kind of tickles the hand, and I kind of move it away. And it starts to build up a theory of mind of the hand having consciousness, not recognizing that the hand, at least as I understand it, and I imagine you'd agree, the hand doesn't have its own consciousness. It's part of my consciousness.
Sorry, is it a human hand or is it an octopus tentacle? Because octopus tentacles probably do have significant self, their own thing going on.
Yeah, exactly. You brought that up in a previous meeting. So how would one empirically deduce, those are the boundaries, as it were, of that system, rather than it just being, I think you've understood my question. Yeah.
Yeah. Okay. So there's a couple of layers to this thing. One is, I'm not primarily a consciousness researcher. I have some thoughts on the subject. In my day job, I almost don't talk about it at all. I've kind of started to a little bit, but basically not. So I don't have strong claims yet about the consciousness. Mostly what I've been doing is talking about cognition, which are publicly observable behavioral competencies of various kinds. Also, up until about a year ago, I have been telling this story of sort of a bottom-up self-assembly and merging of competencies and the scaling of cognitive light cones and that kind of stuff. What I can say now, and the reason I can say this now, and the reason I'm talking about it now, is because it's become experimentally tractable and useful for me to say this. Prior to that, I couldn't, there wasn't anything to talk about, but now there is. So now I can say it. Again, I will just say that I think all of that is a theory of the front end interface. What we are talking about are, when we talk about scaling of cognitive light cones and the memory anonymization that takes place when you have the cells joining together and all that stuff is a story of the interface. The next part of that story is, what is it that comes through that interface? And my current model is that the important patterns that animate these interfaces are in fact not physical at all. These are things that live in this latent space, which some people call Platonic space. Mathematicians study the behavior of the sort of lowest level of that space, numbers and forms and things. Although even that, there's a cool mathematician that has challenged me on that and said, how do you know those are low agency? I think they actually have more than we think. So yes, I should take that very seriously. And so maybe she's going to give a talk at our Platonic space symposium. But there are other forms in that same space that are more complex, more active, and that we would recognize as behavioral propensities or kinds of minds. I think that's where the consciousness actually is. It isn't on this side of the interfaces. The consciousness is the pattern, and what we see is the pattern looking out through specific interfaces. So I think Bernard and I agree on all that stuff. I think that basically what happens here is, and so this is my model of universal steganography, that basically for whatever reason, and that's beyond my pay grade to say why at this point, for whatever reason, the conscious or minimally conscious patterns from that space love to ingress into the physical world. If you make something, whatever you make, you can make a simple dumb machine, you can make a computer, you can make a cell, a biobot, an embryo, whatever you make, all the empty spots, and by empty I mean in the causal structure, all the things that are not forced by either chance or necessity, so algorithms or randomness, all the stuff that isn't forced is going to be filled up with some sort of pattern from the space. Stuff is going to come through. It's under positive pressure or something. It's going to come through. And so some of those things will be very low agency things that only know how to do one thing. They only have like simple goals or whatever. Some of those things are going to be much more significant, and some of those things are going to be very significant. And we don't know very well yet the mapping, because we're constantly surprised. For the biologicals, we've kind of trained ourselves to expect, you see a snake-like thing and you can sort of understand what you're going to get. For some of these other unconventional embodiments, we're totally shocked every time we see it. We don't know. And people call it emergence, basically just, well, guess what? It did something I didn't expect, so it's emergent. It was surprise. But the things that emerge are not just complexity. They're not just unpredictability. Those are cheap and easy. Those are easy to get. No, they're behavioral competencies that any behavioral scientist would recognize if you didn't tell them what system did it. As soon as you tell them, like, well, then that's not real. But if you just look at what it's able to do, then they would say, oh yeah, that's we know what that is. That's Pavlovian conditioning, or that's counterfactuals, or that's delayed gratification, or it's self-modeling, or surprise minimization, or whatever. So that's my story at this point. I think consciousness of different types is basically the view from what we actually are, which are patterns, and then yeah, I mean, in the logical conclusion of all of this, yes, I think those are all sort of reflections of one underlying consciousness. I think that's very reasonable. But for now, I can't do too much with that. But what I can do in the lab is to make use of the fact that we can see the different, for whatever reason, they seem distinct at this point. They seem distinct, and they're doing different things, and they have different properties. And we need to be able to anticipate them, and we need to be able to communicate with them, and we need to be able to have an updated version of ethics that goes beyond materials and evolutionary origin story to be able to recognize things that we have to relate to.
You're muted, Bernardo.
Sorry, just in an attempt to try to help people understand where we connect, what you've been referring to as the interface normally in this group, it's not exactly the same, but roughly is what we refer to as the dashboard, the physical world being the indications on the dashboard, but not the real world, which is on the other side of the dashboard, and which is modulating the behavior of the dashboard. And on the other side, it's mental states, consciousness. And what you're saying is that whatever is on the other side is always trying to modulate the dashboard to express itself through the interface, through the physical. It's percolating through, it's pushing through, and betraying its own presence, given the patterns of indications on the dashboard. So that, I just wanted to build this bridge so people understand where we actually connect. We connect on a lot of stuff, most of it.
And just to give another iteration of the same question, sorry, and Bernardo, maybe you've understood it differently. So another example, let's say we do a bunch of experiments and we discover a river shows problem-solving capacities, it responds in different ways, it has delayed gratification, it will find a way to get to the ocean or whatever. But actually, in reality, again, whatever that is, the river is more like the arm of the mountain. And then we think, oh, the river's kind of its own agent, but actually it's just the arm of the mountain. It is what you're doing, Michael, going to be able to discern those boundaries? Because you've also another time said, oh, there is no boundary. So that's where I'm still struggling to. And in the
Well,
chat, as I scan through, I think it's the same area that people are not always
yeah.
understanding your work, which is
Yeah.
inspiring and amazing. Just to just to emphasize that.
No, it's a good question. I mean, just to be very clear, I'm proposing that all of these are empirical questions. In other words, when you said the water does delay gratification, I actually don't know that water does. I don't think it does. I'm not sure.
Oh, I was just making that up as a hypothetical.
That's the thing, right? That's really important because some people will say, you're crazy. There's no mind in any of these things, and some people say there's no mind anywhere. Like that's a whole other thing. But they'll say no, and then other people say, no, man, the whole every rock has a beautiful spirit inside, and the whole universe, the whole the solar system has this like amazing mind. Like you can't say any of that without actually doing the behavioral testing. You can't just assume any of these things. You have to, and luckily we now have tools where you can now all of this is limited. It's a two-way IQ test, because if I say this thing is dumb, it doesn't do anything, well, that's a statement about you as well. It's like, how smart were you to do the right experiments? The brain's a great paperweight too if you don't know what else it's doing. And so you have to do the experiments. And some of them are very hard. Like people will say to me, "Oh, well, next you're going to tell me that the weather, is a cognitive field." Like I don't know. Have you checked whether a hurricane can be habituated or sensitized? Like I don't. Maybe you can't just say one way or the other from an armchair. You have to do experiments, and some of those are very difficult. But you can't just make this up and have feelings about it. So, the thing what I see is the progressive development of a research program where we at least start with the things that already exist in behavioral science. And actually, there's a whole handbook. If you're facing a new sort of animal, here are the 29 things you can look for. And now we port that to other places, and we've already done it and found new science because guess what? When you apply it to other things without being too chauvinistic about what it should be, and you're a little bit creative about what to look for, you start to find things. And so that's it. It's going to be an empirical question. And then I think we should guarantee that we will never know the full extent of it because, we're limited thinkers. But yeah, it's a research program.
You put emphasis on behavior as the empirical evidence. I tend to, I'm drawn to structure in addition to behavior, but you emphasize behavior a lot.
Only because I hear you, but the reason I emphasize behavior is that I don't think we understand enough about structure to be confident of it. I think people are too they put too much faith in limitations of structure because of assumptions. Not like once we understand the structure better, I think fine. At some point, we'll be able to see without doing all the difficult experiments. We'll be able to look and say, "Oh, I bet I know what's going on," and you'll know what's happening. I think it's way too early for that. I think we don't know. All of our ideas about structure come from an N of one evolutionary tree with biologicals, right, and some fooling around with computers, which I think we don't really, hasn't helped us that much. That's the problem. So someday, sure, but I think it's too early for that.
I get it.
Yeah.
Amazing. Do you have a hard stop at?
Unfortunately, I do. Yeah,
your phone's
unfortunately,
going
I
crazy.
do.
So, all right. So we've just got a couple of minutes. So I'll wrap it up and let us know, Bernard, if you're happy to stay a bit longer. But we'll see you next week, so we can also let you go. But it's just been amazing. Every time you both talk, it's amazing to me. It really stays in my mind and in my subconscious, and it comes through my dreams. It's such a privilege, and I'm so happy you both agreed to do it. And Michael, if you take a glance at the chat, you'll see there's multiple questions people would love to ask. So I know you're so busy, but if there's a gap in your schedule to come back in the near future,
Of course,
I'm sure everyone would love that. And I just want to finish by saying what came through more strongly today, which perhaps isn't talked about, is your motivations, which at one level sounded like it had a lot to do with how beings can suffer. And so I'd like to propose you're motivated by love. And it was just beautiful to see your passion as you come at it from different angles and try and figure it out. And I'm just so grateful.
Yeah, thank you so much, Amir. Thank you for having me here. And Bernardo, always amazing to talk to you. And thank you, everybody. This is a great group. I was just scanning the questions, some amazing stuff. Yeah, I'm always happy to come back and talk
I
to you.
loved talking to you,
Yeah,
Michael.
Likewise. Yeah, thanks, Bernardo.
All right, guys. Thanks so much.
Very good.
Thanks,
Thanks,
everybody.
Bye.
I'll leave the Zoom room open for anyone who wants to stick around. Great. Take care.
Thanks, everybody.
Thank you.